Hello, hello. You guys have a presentation? Yeah. Huh? Yeah. Here, have my quote. Yeah. What had it hold on? Oh, yeah. There you go. Love myself at least. Yeah, good. Nice thing that I'm ready for service.
I got about 2 hours. It's terrible coffee at like 2 a.m.
Coffee.
I've got COVID.
Brian, like really, you want to sit down on this presentation?
What's that?
You want to sit down on this?
I'm your moderator. Are you
Oh
presenting?
shit, no, I'm not. Good thing.
Good, buddy.
Oh,
How's the acquisition?
you want me up there?
Good. That's fine.
Yeah.
Yeah. You get used to something.
I would say that.
Oh, yeah. Let's change it. Oh, it's slow today. Saying not all 2%.
Yeah. Oh, one of these, I'm sure, right? Who's the first presenter? You? Have you used one of these before? Okay. If you want to, if you've got a laser, kind of point stuff.
Oh, okay.
Now, this is, I don't know if they're actually going to be able to watch you virtually.
Okay.
So there's a laser, which is the red button. I can barely see that red. I don't know, maybe you can see it.
Okay. Yeah.
And then if you want to advance or I guess previous. Advance.
Point this.
Previous.
Okay.
I wouldn't mess with these. Just try not to.
Okay.
And you're presenting as well?
I guess, yeah.
Okay, so you've got,
It's gonna be sitting here.
you've got a red laser button, but it's just the red button, and then advance and retract. So, and you're presenting as well?
No, I'm just taking questions.
Okay,
It's your phone.
great. We love moral support. But anyhow, I'll let you have that. And if you want to wipe anything down, we've got Lysol wipes as well as, and when you're presenting that for us.
So I guess
Everybody else would be expected to wear masks, but I'm not for it. But I was going to tell you, you got to turn on the mic if you want to use the
I know
mic.
we talked about that.
So if you want to turn it on, there's a little switch right here.
I'm gonna be presenting.
Yeah. The same thing with the rest of them as well.
Okay.
So if they want to, no, I think that's something you might want to. It's probably all done. I don't know. Let's try this. Let's see if both of them work at one time.
No, I'll just put it away. I think he's talking about,
You mind just kind of talking into that one a little bit?
it's not just showing up for good looks at this.
So what you start, you don't even read it?
I can't hear.
Getting feedback bad though. So probably just, yeah, you'll have to turn off one working. Makes sense?
So during the Q&A, they want to stay seated, we can just turn that off.
And then
Turn these on.
And it's kind of hard to find the switch. They don't make it really easy just to flip up and flip down. But if you have them on, there's going to be yeah, more than one. That's a problem with a small room. If there's any other questions y'all have, there's somebody else you can ask that's me, but I won't know. I'm just,
It's good.
I miss my following comedy. And the rest of you, if you want to, there's some wipes up here if you want to wipe anything down, if you're opposed to that stuff or opposed to germs, because some people are not by nature. So I have kids. Yeah, if you have any questions, I'm going to be sitting back here monitoring. the chats to see if you have any questions. So I'm gonna ask you questions that are coming in from chat.
Okay.
For all of you who are presenting. And I guess you're answering questions too.
Yeah.
So I'll try to speak as loud as I can. If you can't hear me, please tell me that you can't hear me. No, I'll try to speak.
No, we're good.
I'm gonna do that a limited amount. I'm not gonna try to ask, because there's probably gonna be a ton of. And also, we need to do, we actually do, if we can, that's right at 10 till, I think that's, this is 8:50 bedrooms. Because, we still have to set up for the next, which takes a little bit of time with all the junk.
Okay.
And I have to tell everybody to spiel. So anyhow, good luck. Thank you. Yeah.
I don't know that I've ever met a civil engineer with music.
You've been working on this for
I don't think we
Jennifer Hardwick, Brian Aldridge.
Nice to meet you.
The Brian Aldridge.
Yeah, right.
I've heard it.
Good cuss
It's
words,
all-
it's okay.
Yeah, usually
I wouldn't
it
say that.
started with damn or damn Ryan Aldridge. Well, we cut our attendance in half. We were gonna have 20 or so. It's easy, you know what else. I don't know what came in last night.
No, Rick is.
I checked out a couple of sessions. It's also still fun.
Oh.
How much?
I'm fixing everything you messed up.
Okay. My comments, usually about 4,000 or 5,000 people. But so far, like 1,000.
Well, I was signed up to get the session.
Yeah.
I know.
I was hoping I could get into management. It's impressive, you have it.
Jennifer, so he's Brian, not Brian, is Mike going to take care of Daryl's? Oh, okay.
Is Daryl not coming either?
No, I think his wife is a teacher and one of the students tested positive. Is that what it is?
I see. I'm saying
So you're double duty this morning, huh?
that.
Mike Vaughn is going to start talking, so you know.
Oh,
That's
we better get the timer ready.
You'll
Let's
take
get
care of-
stopwatch out.
Yeah,
Take care of it.
just make sure you have a sign, 5 minutes left, 4 minutes left, and then cut the mic off.
When you're ready, I'm gonna get the phone here and do you know how to share the screen? If you want to do it, you can do it. It's up to you.
No, I'm not.
Okay, if you want, I can come up and all I have to do is when you're ready, I'll just come up and hit your screen and you can go on. We're using Zoom, and then this, I've already got your presentation up and running, or a presentation is for this session. I don't know if it's your presentation.
Mike, we gave Brian Aldridge a special mic with a button on it that he had to remotely turn off the mics.
He said I was gonna get a call. I'm disappointed.
Are you the moderator of this one?
Yeah.
So do we have to wear a mask? when we're
No.
speaking?
The mic is like,
I think we can social distance, but
Oh.
the mic
Are you
is,
up here for this one? I mean, I'll be near.
okay. The mic.
So they do have presenter mode. on this.
Is it, can you post it on?
Or it looks it, like the Zoom meeting.
Like that, just first.
Mike, I have a bio for you, buddy. What's? Oh,
I'm
I
not
do. I'm sorry.
presenting.
No, I do. I gave him one. I missed it. It was stuck in the back.
Are you
our virtual friends can join us, we've got to make sure we get the microphone unmuted. A few things we want to go through this morning. This is the only time you're going to have to hear this today, so pay attention, please. All conference attendees, please make sure you signed in at the front table. Make sure you get your training credits, etc. So please make sure you sign in. Also, please download the conference app from the App Store. That was where you provide the most detailed agenda. You're going to search for and download the Crown Compass Events app. And in the Crown Compass Events app, you're going to search for the 2021 ACEC Kentucky FHWA KYEC Partner Conference. Password for the app is Partnering 2021. If you need any assistance with using the conference app, please check in with the conference registration desk. All right. Preferred method for session evaluation this year is actually going to be in that conference app. So that's also how you're going to be able to provide your feedback to the presenters today. So please make sure you do that. You will also be entered in Wednesday night's drawing once for each evaluation that you complete. Please fill out one evaluation per breakout session. Participants will be allowed to win only one raffle prize this year. If your name is called again, you may claim the second prize, but you must return your first prize. Your first prize will then be raffled again. Wednesday's lunch today is going to be from 11:30 to 1 in grand ballrooms A and B. Wednesday night's reception will be from 4:45 till 7 p.m. in grand ballrooms A and B again. Reception will include the vendor hall, prize raffle, snacks, and a cash bar. The green drink ticket that you got with your registration package, it should be inside your bag to be honored at tonight's reception. Okay. With that, I think we're all good to go on the virtual side now. Are we still muted? The microphone's still muted. Can't tell if our Zoom friends can hear us or not. Christian, are we good to go? Okay. All right. Well, with that, hopefully you're looking for the session on innovative intersection projects because that's where you are this morning. With us this morning, Chris Kuntz was unable to join us. He was listed on the agenda, but we got a star-studded group of folks from Prime AE. I'm not going to introduce Harsha because I think everybody in the room knows Harsha pretty well. Brett Malloy is going to be here to help answer any questions you might have. And our main presenter is going to be Jennifer Hardwick. Jennifer chose a career in engineering to follow in the footsteps of her father and both grandfathers. She attended the University of Kentucky and graduated in 2001 with a BS in civil engineering and a minor in music performance. And I mentioned earlier that she might be the only civil engineer I've ever met who has a minor in music performance. And she also mentioned that it's not exactly been useful in her engineering career so far. She spent the past 6 years working primarily on highway safety improvement projects with Integrated Engineering / Prime AE Group. With that, turn it over to Jennifer. Or actually, I think Harsha's going to do a little intro. Oh, okay. Thank you.
All right, thank you for the introduction, and thank you all for joining us this morning for our presentation discussing some of the innovative intersection projects that we've worked on as part of our highway safety improvement program contracts. I'm going to start with just a basic overview of innovative intersections. What are they? Why should we care? And where can we use them? Can you all hear me, by the way? I know I don't speak very loudly. Okay, I'll talk a little bit louder. Innovative intersections are intersection configurations that modify vehicle, pedestrian, and bicycle movements. And a lot of these modifications deal with ways of accommodating the left turn movements that can contribute to congestion and collisions at intersections. And so because of this, innovative intersections can provide efficiency and safety benefits. Why should we care? Well, if you look at this picture up here, this is a scenario that's becoming more common. You have an intersection that's experiencing a lot of congestion, but you may not have the room or you may not have the budget to reconstruct the intersection or add more lanes. And there's only so much tinkering that you can do with things like signal timing. So at some point, we're going to have to start looking for innovative solutions to deal with these issues. Another reason we should care is that you can think of intersections as planned conflict points along a corridor. And these can be conflicts between two vehicles or vehicles and pedestrians or bicycles and pedestrians. And each one of these conflict points is the potential for a collision. I'm gonna go out on a limb here and say that everyone in this room went through at least one intersection on your way to the conference. So things like conflict points and potential collisions, these are things that can potentially affect all of us. In fact, in 2020, intersection crashes made up 18% of fatal collisions in Kentucky and 33% of injury collisions. And of these intersection fatalities, right angle and left turn collisions, some of these collisions that innovative intersection layouts are seeking to mitigate made up over 60% of these collisions. And finally, where can we use them? Well, we can use them in a lot of places. We can use them in rural settings or in urban settings, 2-lane highways, multi-lane highways, divided, undivided, 3-leg, 4-leg, 5-leg intersections. There are a lot of different types of innovative intersections, and they can apply in a lot of different places. So we've been fortunate enough to have been selected for 4 HSIP contracts, and through these contracts, we have been exposed to a lot of different innovative intersection projects. But for this presentation, I'm just going to focus on these 3 here. We have one in Knox County, one in Whitley County, and then one project that's actually 2 intersections in McCracken County. And I'm going to give you kind of a cradle to grave overview of the process that we went through for each of these intersections. So the first intersection that I'm going to talk about is in Knox County. It's the intersection of US 25E and Kentucky 3041. And this is on the west edge of Knox County. It's almost due east of Corbin. And in fact, the south leg of the intersection there is the Corbin bypass. 25E through here is, it's an east-west direction. It's actually a north-south road. It's a divided highway. You have 2 lanes in each direction and a depressed median. The existing intersection is signalized. And you can see there's been a little bit of development on the east side of the intersection. In the southeast quadrant, you have a gas station and a car dealership. And then in the northeast quadrant, you've got a mining company and a couple other small local businesses. So when we were first assigned this project, we went out and did an initial site visit. And this is what the intersection looked like at the time. You can see that District 11 has already implemented some low-cost safety improvements. They've installed reflective backplates on the signal heads. They've got flashing yellow arrows and offset left turn lanes for US 25. But despite this intersection was still experiencing excess expected crashes. So it was assigned to us as an HSIP project. And our job was to look at the crashes, look at the physical characteristics of the intersection, and just come up with some potential improvements that might help mitigate some of these issues. One of the early things that we did was we took traffic counts. We have mile vision cameras, and we went up there. We did AM and PM counts, 4 hours each period. And these are just the results of the counts. And you can see that the heavy movement is a through movement on 25 in both directions, but also the right turns from Corbin bypass on the southbound 25 and the left turns from 25 onto the Corbin bypass are also relatively heavy as well. And then the north leg of the intersection, that's Watch Road. That's, it's just a local road. There are a handful of houses. So the volumes for that leg of the intersection are relatively much lower. And one of the first things that we always do for our HSIP projects is we do a 5-year crash analysis. And that's just where we pull all the crashes for a 5-year period. And we sort and filter them in different ways. And we're just looking for patterns in the crashes. So we might sort crashes by near collision, like I have shown there. We might also look at time of day, wet crashes versus dry crashes, directional analysis, whether the crashes occurred in the daylight or in the dark, just things like that. Anything that we can think of to get a better picture of what kind of crashes are occurring at this intersection. So when we did that for this intersection, 3 things stood out to us. And first was that there were several northbound rear end crashes that involved injury. And when I say northbound, I mean northbound 25. And the little Google Earth screenshot there on the lower corner of the screen, each one of those dots represents a crash. The light blue dots, those are the rear end crashes. And you can see they're kind of clustered in the northbound lanes. And it's not necessarily unusual to have a lot of rear end crashes at a signalized intersection, but what was unusual was that 46% of these crashes resulted in injury. Because rear end crashes tend to generally be lower severity. So that kind of stood out to us. Another thing we noted was that there was a relatively high percentage of angle crashes. And these were left turn related, but also some right angle crashes as well. And they also have a high percentage of injury. And then finally, there were 3 head-on collisions, and all of these resulted in injury, and all of these occurred on US 25. So we kind of combined all this information, we put our heads together with the project team, and we decided that we were going to look at combining a restricted crossing U-turn and a continuous green T layout at this intersection. What is a restricted crossing U-turn? And I had to share this article headline that I found when I was looking for the conflict points diagram. An R-cut is not a piece of meat. I did get kind of a giggle out of that. But an R-cut is an innovative intersection layout in which all movements from the minor approach first begin with a right turn. So if you're on a minor approach and you want to turn left, first you turn right, and then you make a U-turn at a point about 400 to 1,000 feet down the main line and come back the other direction. If you're on a minor approach and you want to go straight, first you make the right turn, then you make the U-turn, and then you come back and turn right onto the other side of the minor street. And this layout has both safety and traffic benefits. And the safety benefits, a lot of that deals with the conflict points. I'm sure you all have seen the conflict point diagram for a conventional 4-leg intersection. You've got 32 conflict points. An R-cut has only 18 conflict points. Then the thing about an R-cut is not only are you reducing the overall number of conflict points, but you're reducing the severity of the conflict points. So you still have the merging and diverging conflict points, and those tend to be more your side swipe type crashes that often have a lower severity. But for an R-cut, you only have 2 crossing conflict points. And these are your left turn crashes and your right angle crashes like we're seeing in our intersection. And in fact, theoretically, an R-cut layout completely eliminates the potential for far side right angle crashes that tend to be higher speed and therefore higher severity. And because of the channelization and the median islands, you can also reduce potentially your head-on collisions as well, like the 3 that we saw on 25 for our intersections. So studies have shown that when you convert an intersection to an R-cut, you can potentially see up to a 35% reduction in all crashes and up to a 54% reduction in injury crashes. As far as the traffic benefits, that has to do with no longer needing to provide a phase for the minor street through or left turn movements. So you can provide a little bit more green time to the major street movements. You can treat both of these directions as kind of independent one-way streets, and that can help with the efficiency of the intersection. A continuous green T is an intersection layout that's generally used at a 3-leg intersection. And obviously our intersection is a 4-leg intersection. But if you think back to the traffic counts that I showed, the north leg of the intersection, Watch Road, has relatively very low traffic volumes. So our thinking was that instead of treating this as a 4-leg intersection, we could treat it as a 3-leg intersection with an entrance. So how a continuous green T works is you have one direction of the major traffic that's a continuous flow. They don't stop at the intersection. And then the left turns from the minor street turn left and then merge into that continuous flow movement. And again, this has safety and traffic benefits. For the safety benefits, because of the channelization, you can potentially reduce some of the angle crashes, but a little more applicable to our intersection, because you have that free flow movement, that reduces the opportunity for those rear end collisions that we're seeing at our intersection that are resulting in injuries. So studies have shown that if you convert an intersection to a continuous green T, you can potentially see up to a 15% reduction in fatal and injury crashes. And then there are traffic benefits as well. Because of the channelization, you can potentially reduce some of the angle crashes. And have I said this already? Oh, no, wait, I'm talking about safety. Traffic benefits are just because you have a continuous flow movement. The vehicles don't stop, especially if it's a heavier flow. You can get more vehicles through the intersection. So we decided that at least safety-wise, this looked good, but we did need to do a little bit of traffic modeling just to make sure that our proposed layout was going to work with the traffic. And I'm not going to go into a lot of detail about either the modeling or the results, mainly just because we don't have the time. But our traffic engineer, Brett Malloy, did a lot of the traffic modeling. So if any of you have any traffic-related questions, he would be happy to answer them after the presentation. So these results here are just the results of our traffic analysis. And we basically looked at 4 scenarios. We looked at the no build scenario with existing traffic, the no build scenario with 25% growth, the proposed layout with existing traffic, and the proposed layout with 25% growth. And we looked at the level of service and delay at each of these 3 points on the intersection. And we just kind of combined them all into one chart, just so everybody could look at everything all at once and make sure that our proposed layout wasn't going to completely blow up traffic. And then we also looked at average travel time for the intersection. And again, I'm not going to go into too much detail about the actual results, but the average travel time is just how long it takes to get from one point to another at this intersection. And you can see, looking through that chart there, that for a lot of the movements, the travel times don't really change all that much. But there were a handful of movements, and all of those dealt with the watch road flag that did increase a little bit. And I have one of them boxed out here in red. This is the movement to go from point 3 to point 1. So in the existing intersection, you can see that obviously traffic is just going to go straight through. And that's going to take about 39 seconds. But with the proposed layout, when those vehicles have to make the right turn and come back and make the U-turn, that's going to take about 107 seconds, which is an increase. And that raised some eyebrows at first. But then if you look at the volume, there are only 5 vehicles that are making that movement. So after a lot of discussion, we decided that that was going to be an acceptable trade-off. Some vehicles were going to have longer travel time, but we were going to get all the safety benefits and the traffic benefits for the other ones in the intersection. And this is just a quick clip from one of the Vista micro simulations that we did. This is the PM peak with 25% growth. And here you can see the vehicles on the corridor bypass have the green light. So the left turns are turning onto northbound 25 and then merging into that free flow movement. And then when that light turns red, you have the left turns from 25 onto the corridor bypass. And that's the exact same movement that vehicles are making today. And then finally, you have the southbound 25 traffic, and the through movements and the right turn movements are the same that vehicles are making today, but we're no longer permitting vehicles to turn left directly onto Watch Road. So all that looked good, and we decided to go ahead with laying out a proposed design. So then we had to think about some of the ways we were going to design this. One of the big things that we had to think about were the looms, and those are the pavement bump outs at the U-turn points. And these are provided so that the heavy vehicles can make those U-turns without driving off into the grass. We had to figure out how big we wanted to make those and how far from the main intersection we wanted to make the U-turn points. So what we ended up doing, we used auto turn, and we ended up going with a 100-foot diameter for the looms because that would accommodate the WD-67 trucks. And as far as distance from the main intersection, for the loom on the right, the U-turn point on the right, we went at about 600 feet from the main intersection to be within that 400 to 1,000 foot range. And then on the left side, where we were trying to accommodate the acceleration lane for the continuous green T, we had to put that U-turn point out a little bit further because we wanted to minimize the weaving between the vehicles that were trying to get onto 25, merge onto 25, having turn left off of the bypass, and the vehicles that were trying to get off of 25 to make that U-turn point. And so we also had to think about the length of the acceleration lane for the continuous green T because we wanted to make sure that those vehicles were able to get up to speed so that they can merge on traffic on 25. We also had to think about whether or not we were going to signalize the R cut. You can have signalized and unsignalized R cuts. And if you have a signalized R cut, you have some options there as well. You can have either the signal at the main intersection, or you can have a signal at both U-turn points in the main intersection. And this is something that we use the results from our micro simulations for. We were able to run different scenarios, and we determined that we were going to need, this was going to be a signalized R cut and continuous green T, and we were just going to need a signal at the main intersection. We also had to think about the entrances. We had those businesses, we had the gas station, the car dealership, the Hardwick company. We had to figure out how we were going to give them access points to US 25. What we ended up doing was making those entrances right in, right out, because they're fairly close to the main intersection, and we didn't really want people turning left and creating more potential conflict points. So we achieved that by concrete islands just some channelization to force those vehicles to turn right out of the entrances. And then finally, approach roads, we had to decide how many turn lanes we were going to provide on the minor roads. And again, that was something that we were able to look at with our micro simulations. And what we ended up going with was one left turn and one right turn on the bypass, and then one lane coming out of Wash Road. So this is what a combined continuous ring T and R cut looks like. And you can see on the right side, the U-turn point is shifted much further from the main intersection. And that's just to give us enough room for the vehicles trying to merge onto 25 to get up to speed. You can see we do have a couple of existing median U-turn points that we're showing as taken out, and that's because we want to force these people to make U-turns only at the U-turn point that we're constructing. We don't want them to just make U-turns anywhere. And then you can see the right in, right out entrances and all the channelization. So that's all I have for that intersection. Now I'm going to turn it over to Harsha to talk about Whitley County.
Jennifer's doing all the hard work, and she asked me to get up here and explain a couple of simple slides. Whitley County roundabout, US 25. If you're heading south on I-75, it's just near Williamsburg. We were tasked with HSIP by Mike Vaughn and his staff to look at these two intersections after the on ramps and the off ramps on 25. Okay, so this is during a site visit. As you can tell, the white car over there, they've already missed the on ramp. Point this out. This white vehicle right here was supposed to make this left turn, and they went it, and they were making this turn right through here that is supposed to be the on ramp coming on 25. This one of the issues with this intersection, there was side distance issues because of the rock outcroppings and the bridge that's on 75 as well. So we did aim counts and PM counts at both the ramp terminals and all on both the intersections. And as you can tell here, these are color coded, and the volumes, the bandwidth essentially versus the number of volumes and so forth. This is one of the anomalies, like one of the people, when we were doing the traffic counts, they essentially cut off the road and they just went across and cut back on the interstate again. So as part of our crash analysis for the roundabout, we looked at a 5-year period, and we were trying to analyze existing data to figure out what exactly is going on, what are some of the issues that exist within these intersections. With the southbound ramps, there were quite a few angle collisions. As you can tell right through here, on the southbound, we had approximately about 33% angle collisions. And on the northbound, the opposing left turns were the big thing. And this was also to do with side distance issues and people getting confused on where they should be getting on the ramps and off the ramps. And we also had some rear ends as well, which was approximately about 38%. So why roundabouts, right? I think everybody in this room is pretty familiar with roundabouts. They've been around for a long time. The big takeaways, if you take a typical signalized intersection such as this here, we essentially have 32 conflict points. And for pedestrians, there are 24 conflict points. So when you go from that to a roundabout, you essentially go from 32 conflict points for vehicles to only 8. And the same thing for pedestrians as well. You go from 24 to 8. And one of the key takeaways of this, with intersections, you have some major conflict points. And usually when these things happen here, usually you're getting teeth, the chances of injuries are pretty high and the severity is pretty high. With roundabouts, it's mostly, when you're doing these movements here, it's mostly like side swipes, less chances of injuries and less fatalities as well. In our project, we essentially achieved a 24% reduction in crashes by the two roundabouts. And approximately, we were looking at a benefit cost of about $800,000 in 5 years. Okay, we did level of analysis on the roundabouts. Essentially, we did traffic projections for the next 20 years and did analysis on that. And as you can tell, going back. As you can tell here, both the roundabouts operating really well. All of the legs at essentially the level of service A. And the worst one was northbound off-ramp, where we had approximately about 11 seconds of delay. So some of the design considerations when we looked at this roundabout, when we were looking at putting the roundabouts, and a couple of things came into play. The super elevation of the existing 25 out through here and here. The grades of the on-ramps and off-ramps are rather steep. And essentially we have a bridge over here as well, and we want to make sure that we did not impact the bridge and keep the bridge in play. Several of the quadrants right through here, the north quadrant, these were pretty large. I mean, when I say pretty large, they were about 25 to 30 foot tall rock outcroppings that this was cut to construct this right through here. And on the southern part, right through here, there were some steep drop-offs. So when we were looking at putting these roundabouts in, obviously one of the big things about HSIP is to stretch each and every dole as far as we can and to achieve the results without spending too much money. So we went through several iterations on what the diameter of the roundabout should be and how to place it. So some of the challenges we ran into, we had to accommodate for the heavy vehicles as well to make sure that the heavy vehicles can make the movements. We had to make sure that there's adequate sight distance because of the rock outcroppings in the bridge. And the other thing was when we are essentially, once we construct this, how do we tie in some of these grades? We did not want the roundabout to be lopsided. We want to make sure that anybody that's traveling on it had a smooth transition, smooth travel way. So one of the roundabouts here, this one right here, ended up being about 105 foot radius in stripe diameter. And this one was 110 from what I recall. And what else am I missing? So one of the things in here, going on the next slide, we had to take into consideration some of the pavement, like what are we going to do with the pavement? And we had some discussions with HSIP folks and central office and district folks as well. Are we going to overlay on top of the concrete? Are we going to do a full depth replacement? We had some elaborate discussions on how to do that and MOT impacts and so forth. And finally, we decided that the best thing to do would be take out the existing concrete and to use asphalt, that we would have a better product in the end. And also with the super elevation transitions too, we were having a really hard time with trying to make the existing pavement work. So for construction, we essentially, for MOT, we couldn't face it. We couldn't face the roundabout because the sheer grade differences. In some of the ramps, we were essentially adding about 2.5, 3 feet to each of the legs. So we decided to essentially shut these down during construction.
All right, and then the last project that I'm going to talk about is actually 2 adjacent intersections in McCracken County. And we were assigned this through our HSIP contracts to look at the feasibility of converting both of these intersections into restricted crossing U-turns. And US 60 is a divided highway through here. This is west of Paducah. You've got 2 lanes in either direction and a depressed median. We have a fairly good amount of right of way, about 200 feet at the narrowest point, and that's at the church there that you can see labeled in the northeast quadrant of the right intersection. And then it's about 240 feet of right of way throughout the rest of the project. The intersection on the left is Kentucky 726, and the existing control for that was 2-way stop control. And then the intersection on the right is Kentucky 996, and that was a signalized intersection. So again, one of the first things that we always do is look at 5 years of crashes, and these are just the results when the collisions are sorted by manner. And you can see that both of these intersections had a fairly high percentage of angle collisions. 726 had 78% angle collisions, 996 had 67% angle collisions. And both of these intersections also had a really high percentage of injury crashes at 61% and 56%. So if you think back to when I was talking about R cuts and safety benefits earlier, you can potentially see up to a 54% reduction in injury crashes, which in our case corresponds to a crash benefit of about $1.5 million in 5 years. And this is just a way of measuring the economic benefits of implementing a safety countermeasure. It includes direct costs and indirect costs. And your direct costs are things like your lost wages or your medical bills, and then your indirect costs are your quality of life type issues. So this is just a way of kind of quantifying the impact to the public of these improvements. And if we can convert both of these to R cuts, we're looking at a potential benefit of $1.5 million. And we did traffic counts at each of these intersections as well, again, at AM and PM peak. And then we put all those traffic volumes into CapEx. And if any of y'all are not familiar with that, it's a spreadsheet that was developed by the FHWA. And basically you just put in your traffic volumes and it kind of ranks different configurations of innovative intersections to give you kind of a high level planning overview of how each one might potentially perform. And so these results here are for the Kentucky 726 intersection. We have the AM peak and the PM peak. For this one, we looked at the two-way stop control because that's the existing condition, and then also the unsignalized and signalized car cut. And you can see that for both of these, in the morning, the two-way stop control performed a little bit better, and then in the PM peak, the unsignalized R cut won out. But overall, the volume to capacity ratio of each of these layouts, they're all pretty good and are all fairly similar. So for this intersection, we decided that we were going to go with an unsignalized R cut layout. And then we did the same thing in Kentucky 996 and came up with similar results for that one as well. And so we decided that we were going to look at unsignalized R cuts for both intersections. And then again, we had to look at the proposed design and how we were going to handle some of these elements. We had to look at the looms, how big do we want to make them, how far from the main intersection. We had to think about the turn lanes, how many do we need to provide, and the U-turn lanes as well. We had to look at the pavement design, and then something that was a little interesting on the Kentucky 996 intersection is that there's a slight horizontal curve on the east leg of that intersection. So we had to figure out how we were going to work in the super elevation as well. And these are the proposed layouts. On the top, you have Kentucky 726, and each of these U-turn points are about 700 feet from the main intersection. And we made the looms, they have a 95-foot diameter. Again, that's to accommodate the heavy vehicles making those U-turn movements. And then we provided one right turn lane for each of the minor approaches, but we only striped out the middle lane. And this is so that in the future, if traffic volumes go up, all the district has to do is some restriping, and then they can provide two right turn lanes. We started the U-turn lanes as close to the main intersection as we could. And the reason behind that is that we want the right turn vehicles to basically be able to make a smooth movement into that U-turn lane, because that minimizes the amount of time that they're spending in the US 60 through lanes and can potentially minimize the conflict points and the collision potential. As far as pavement design, we were lucky we found some relatively recent archive plans that had a pavement design, so we were able to match the depth of the existing pavement. But for the proposed full depth pavement, and that's the darker shading there with a kind of speckled shading, we decided that we were going to use fiber reinforced asphalt. And that is asphalt that's just been mixed with aramid fibers, and that can provide a little bit more strength and durability for the pavement. And we decided that because of the truck volumes, we wanted to potentially give the pavement away to last a little bit longer. And then on 996, you can see on the left side of the intersection, it's fairly similar to Kentucky 726. Again, we have that U-turn point about 700 feet from the main intersection. We have the one right turn lane coming off the minor approach and the U-turn lanes. But on the right side of the intersection, the U-turn point is pulled in a little bit closer to the main intersection. And we did that for two reasons. First, you can just barely see the church parking lot in the upper right corner of that picture. There is an access point on US 60 from the church And we wanted to shift the lane a little bit closer to the main intersection so we didn't have a conflict between the vehicles turning in and out of the church parking lot and the vehicles making that U-turn movement. And then the other reason that we shifted the U-turn point a little bit to the left was that the church is where we have the narrowest right of way. And we were trying to avoid right of way impacts. And so if we put in a 95-foot diameter when 700 feet from the intersection, we were going to be in the church property. So shifting it over and making the loom only 90 feet still accommodates those U-turning vehicles, though we were able to stay off of the church. And then you can see the horizontal curve on the right side. And that was causing us a little bit of a headache at first, because when you add that extra U-turn lane, that lowers the edge of pavement elevation. And it also narrows the horizontal distance that you have between the two edges of pavement. So that gives you a much deeper cross slope, and that was kind of creating drainage headaches. So how we ended up handling this is we used the concrete islands and then storm drains to kind of help with both the super elevation and elevation difference and the drainage issues. And then we did detailed sign plans for both of these because sign is very important. These are still fairly unusual in Kentucky, and the sign just gives the drivers a better idea of where they need to go and what they need to do. And then we worked with Central Office Traffic on the lighting design. And we were originally signed these intersections at the end of September in 2019. And we were able to submit plans for lighting in April of 2020. So that was a period of only 6 months, and they are currently under construction. So I'm excited to see how they turn out. That is all I have as far as my presentation. Do any of y'all have any questions?
On the last intersections there, how far apart were those two intersections?
I forget the exact distance.
It was a mile and a half, right?
It wasn't very long. They were fairly close.
I think 2,400 feet.
That sounds about right.
I think the access spacing was 1,200. You've got one median crossover about halfway. I think it's 2,400 feet.
All right.
I got 2 questions actually. What was the spreadsheet you said that Joy used this?
CapEx.
CapEx, okay. Thanks. And then on the roundabout, the reason you guys didn't make it a dog bone, it looked like you're allowing the through movement on both sides.
The biggest thing, Kyle, was the, pretty much the bridge. We were trying to go up to the existing, but we just couldn't get it in place.
With CapEx, there's another spreadsheet called SPICE, and that's safety performance of intersection control evaluation. So they're like sister spreadsheets. Once you put everything into CapEx, you'll get results. The data that goes into CapEx just merges into SPICE, and then it'll do your safety performance calculations. And there's probably 15, 20 different intersection types you can have it, those spreadsheets look at.
Yes.
Is there any data to support rear end load in the looms? You know, the person's making that movement. Does that lend itself to the potential for rear end crashes?
Yeah, the potential's there. If you want to flip to one of the layouts. So it's a little hard to see, but one of the things we've been doing in Kentucky is we add an auxiliary lane from the looms back to the main intersection so that anybody that originally wanted to go through, they never actually have to get into the opposing through lane traffic. That also allows for acceleration to minimize the potential of someone taking a short gap and getting rear-ended. But so far, our experience has been that we don't really have crashes at the U-turns. I think a lot of people know that movement takes a lot of time to pull off, and so they just take better gaps when they feel that threat level is different. I think at regular intersections, people just get complacent with doing the same thing all the time and go through the motions. We've seen really good success in most other states too.
kind of sight distance did you use to calculate up for that movement?
So we've looked at a lot of videos online that other states have produced to talk about their R cuts, and a large truck tends to be the control vehicle. They just take so much longer, and our estimation is it takes them about 12 seconds to maneuver through a U-turn. And so then we try to consider, well, what's the actual speeds out there? And then, you know, well, somebody's going 60 or 65 or whatever it is, and how, you know, they're going to be there, or the conflict's going to be there for about 12 seconds, then how far back does that truck need to see? And a lot of times those sight distance from the U-turn point out along the main line, you need over 1,000 feet. Luckily, most of our 4-lane divided roads in Kentucky have really smooth profiles, and you can see 2,000, 3,000, 4,000 feet. So we haven't found very many where we've ran into sight distance issues. We've had some where the crest is just enough that a vehicle will hide. And so we've had to take the U-turn lane a little further out to position them kind of at the top of the crest, so then they have unrestricted sight distance. But that's a good question. I tell people that the U-turn sight distance is probably the most critical piece of the design, because if you can't see far enough to get a good gap, you're going to make a mistake. So.
Anybody else? Any questions come in online? All right. Well, thank you again for your attendance this morning. Please make sure you download the conference app and provide your feedback to the presenters this morning. And with that, that concludes our session. Thanks for attending. I meant to ask you earlier, this omnidirectional mic, do we need to repeat the questions so people online can hear, or in the back they can hear okay? I assumed that was the case, so I didn't. Well, obviously, just let people ask the question.
Part of the virtual here.
Well, we're in here all night. Make sure
That's kind of, and sometimes you get it.
No, I should, yeah, I agree. I like this.
Yeah, I know.
When it's we're the closest presentation room to my room. So, you know, they know I'm always in the lane. At least, but
I know.
closest room.